Amazon API Gateway is an AWS service for managing APIs at any scale. REST APIs and HTTP APIs are both RESTful API products offered by API Gateway. While HTTP APIs are designed with minimal features and cost-effective, REST APIs provides more advanced features such as API keys, per-client throttling, request validation, private API endpoints, etc. In this video, let's get started with REST APIs in Amazon API Gateway. We will learn the different building blocks of REST API, how they connect with each other, and how you can configure and build an API in the AWS console. I will be using a mock integration to demonstrate the different features. In the follow-up videos, I will show how to connect with other AWS backend services to build a real-world API. However, a good understanding of these basic building blocks is necessary to build on those integrations. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Azure, AWS, and DevOps. Before we go any further into exploring API gateways, let's get one thing clear. Both REST APIs and HTTP APIs helps us building RESTful APIs. The REST word in the REST API is purely a naming thing and not to be confused with RESTful services. Now, if you're looking to build a minimal and cost-effective API endpoint, you can check out my video on building HTTP APIs, which will be linked here, also in the description below. But if you're here to build a feature-rich API endpoint, let's jump right into building REST APIs. I have my AWS console open here, so let's navigate to API Gateway. You can either navigate from the recently visited if you have recently visited it. If not, you can use the top search bar and type in API Gateway and navigate from there. Once you're in the API Gateway dashboard, you can choose the API type that you want to build. It provides HTTP API, WebSocket, and also REST API. Let's click the REST API and say Build. Now, if you already have a definition, you can use the import option as well. But let's get started with a brand new API. So click Build. Now this prompts you that there is a pre-populated API that you can use in case you want to play around. Let's click OK and let's select the new API instead of the example API. So let's click New API and choose an API name. In this case, let's give this a name, YouTube-REST. Let's give a description. So let's give this as YouTube sample REST API. Let's keep the endpoint type as regional. The other option is edge optimized and also private. You can learn more about these options by hovering over this information. You can see regional APIs are deployed in the current region, whereas edge optimized are deployed to the CloudFront network, whereas private APIs are only accessible from the VPCs. So let's leave this as regional and let's click Create API. This creates a brand new API endpoint for us and it opens up the API Gateway console. Now this has lots of different options which we will be going through and exploring in detail. By definition, a REST API in API Gateway is a collection of resources and methods that are integrated with backend HTTP endpoints, Lambda functions, or other AWS services. Now the keywords here are resources, methods, and integrations. These are the three building blocks of building a REST API. We will explore each one of them as we are building our REST API. So let's navigate back to the console, and here you can see there is a root path which is simply a slash. Now if we click the Actions button, you get the different actions that you can perform on this particular resource. The first thing is to create a new resource. Resource is a fundamental concept in building RESTful APIs. A resource is an object with a type, associated data, relationships with other resources, and also a set of methods that can operate on it. Now once we click the Add Resource button, we can add a new child resource to this API endpoint. Let's give this a name. So let's name this as users. So this is the users resource inside our API. So once you enter in the name, it automatically determines the resource path. You can modify this if you want, but let's leave this as users itself. Resources are uniquely identified by this path. Now in our case, the slash users path of our API URL is going to identify the user's resource. You can also enable API gateway calls by checking this box if required. Let's leave this as unchecked because right now I wouldn't be needing it. And let's click Create Resource. This creates a new resource node which is users under our tree under the resources section. Now we saw that the next fundamental building blocks are methods. By selecting the users resource that we just created, let's click the actions button. It gives us an option to create a method. So let's click create method. This gives us an option to select the method. Now these are the different HTTP verbs that you can use to operate on this resource. So let's select get and select this check mark. This sets up the get method on our newly created users resource. For setting up the method, we get different integration options. You can either choose to integrate with a Lambda function or an HTTP endpoint or use mock endpoints or other AWS services. You can also use a VPC link integration. Now, if you see for these options, you can also see there is an option to use a proxy integration. Now, this is available with Lambda functions. Even if you switch over to HTTP, you can see a similar option and for certain other integration options as well. Now, whenever you're connecting with an integration backend, there are two modes by which you can do this. One is referred to as the proxy integration mode, and the other one is the non-proxy mode. With the proxy integration mode, the request that comes to this endpoint is passed as is to the integration backend, which means the HTTP request that comes into this API will be passed exactly as is to your backend. It will be the backend service's responsibility to parse out the information required from the HTTP request object. With the non-proxy integration, we can use mapping templates to map the incoming HTTP request into backend specific formats. So you can extract out all the information from the HTTP request and pass just the bare bones required information to your backend services. For example, if you're building a Lambda function, if you're using the proxy integration method, the Lambda will need to parse the HTTP request object. However, if you're using the non-proxy integration method, you can pass in exactly what the Lambda needs. Let's say if it needs to add a user, you can just pass in the user object to your Lambda function. All the parsing and interpretation of the HTTP request will happen on the API gateway side. In future videos, I will show you exactly how to build Lambda functions using these two different modes. For now, let's select the mock integration option and see the different building parts of this method option. So let's click save and it sets up the different options for the get method that we have just created. In API gateway, an API method consists of a method request and a method response. Now the API method defines what the client must do to submit a request to our backend services. Now the API method request is simply but an HTTP request. The method request consists of the HTTP method verb, which we saw in our example was get. It also sets up the path to an API resource. You can specify the headers and applicable query parameters, etc. We will see how to set this up in the gateway in a moment. The API method response, whereas, is the HTTP response with a given status code. Now the same endpoint can have multiple method response. Now when you're building APIs, your APIs might return different 200 status codes, 400 status codes, and also 500 status codes. This is why an HTTP method can have multiple responses. Let's see how to set up the method request and the method response inside the API gateway. If we navigate into the method request, we can see it gives us different options to set up the authorization, a request validator, and also API keys. It also gives an option to specify the query string parameters, the request headers, the body, and also other SDK settings. Now if we come back to our method response, you can see by default it is set up with a 200 status code. Now if we expand this, you can see this is automatically set up for the content type application/JSON by default. It is currently responding an empty response. So if we navigate back, you can see here that any request coming to the user's resource via the get method comes in to the method request. This then goes to the integration request, which is currently set up as a mock, It then comes to the integration response and back to the method response. An integration request is an HTTP request that the API gateway submits to the backend services. It passes the client submitted data. It transforms it if it's required, depending on the proxy or the non-proxy mode that the integration is set up. It can also pass along the HTTP method and the other information that's along with the HTTP request. Now, similar with the method, the integration also has an integration request and an integration response. In this case, we selected it as a mock integration type. So let's select this and configure the mock integration. Here we have the option to configure the mapping template. Now, as we have seen, an API's method request can take a payload in different formats. Sometimes the data can come in query strings, sometimes in the body, or you might even have valuable information inside your header. Now, when you're using the non-proxy mode of integration, your backend services would be expecting the data in a different format. Now, these mapping templates can be used to bridge the gap between the HTTP request and what the backend services expect. Now, a mapping template is a script which is defined in the Velocity template language. So let's come back here, and right now we have a mapping template if the content type is application/JSON. This is the default option that is set up when we created the endpoint. If your APIs support other content type, you can add a new mapping template in here. Right now, the application/JSON mapping template is simply configured to pass along the status code as 200. You can also see the integration pass-through options right above. This is the request body pass-through option. This has three options in here, which says when no template matches the request content type, when there are no templates defined, which is recommended, or which is never. Let's understand these three different options from a table inside the documentation. Now, this is assuming we have an integration request mapping template defined for the application/JSON content type, just like in our example before. Now, we have the different content types that can come into your APIs and the three options that we just saw, which is when no match, when no templates, and never. By default, if there is no content type header specified, it defaults to application JSON. In this case, all three options selects the application JSON mapping template. Now, when you have explicitly selected a content type, it behaves exactly the same as default options. Now, when the content type is application/XML, when the option is a no match, the request payload is sent as is to the backend. There is no transformation applied because we have selected when no matching templates is found, pass through the request. Now, if it's the case of when no templates, this request with the application/XML content type will be rejected. So when there is no templates that's defined, it will reject that particular request. The same is with the option never. The request is rejected with a 415. So the recommended option here is to specify when there are no templates defined. This ensures that none of the requests which doesn't have an appropriate mapping template doesn't go through to your API. But if you're using the proxy mode, you can very well select it as when no template matches and handle all your requests in your backend services. So let's select this second option and let's click Save here, which is basically to save this template. So let's navigate back to our integration response and see how this is set up. Now, the integration response is basically mapped against the status codes. You can see here, by default, there is one record which handles all status codes coming back from your integration server. It sets up a default 200 response code for any status code that's coming from our integration backend. Now, in this particular case, there is a mapping template again here, but there is none defined right now. So in this case, even if our backend was giving us a 500, this would capture that and return it back as a 200. So let's navigate back and let's select test to test this API endpoint. By simply clicking test here, this invokes this API endpoint that we have currently set up. You can see the path that this request is taking in the logs here. So you can see the execution request is started. It's getting the resource path/users, the request path, query string, headers were all empty. Since we don't have any transformations, those are also empty. And you can see it's returning successfully with a 200 response. Now the response body is also empty, because of which it's showing as no data. Now if we want to send back some data, let's go into our integration response. Let's open this and edit our mapping template. Now let's specify application/JSON. So anytime a request matches this header, this is going to use this response template. So we can say hello REST API in this case and click save. Now if we come back to our API method and click test and select test, you can see that this text message is returned in our response body. Now like we saw in the integration response, any status code is getting transformed to a 200. But let's say our integration backend is going to set up 500 in this case. So instead of specifying status code 200, let's specify 500 and click save. Now if I was to go back and test this again, it is still going to give me back 200. This is because our integration response is capturing all the status codes and transforming it to 200. To fix this, let's first add a different method response to our endpoint. So if we navigate to this, we can see currently we have only a 200 status code defined on the method response. So the integration service cannot map to anything other than 200. Now let's add a different response and select 500 in this case. And let's select this. Now once a new response type is defined inside the method response section, we can go back to our integration response and start mapping out a different integration response. So let's add a new integration response. Let's say 500 in this case. Let's select the response status as 500. This is what is mapping to the method response status. And let's specify content handling as pass-through and click save. This sets up a new mapping. So whenever a 500 response is coming back from the integration, it transforms that as a 500. Let's tick this and let's specify the message error calling API and let's click save. Now if we come back and test this, this is going to return error calling API because of the 500 status code. You can also add a regular expression-based matching. So instead of using 500, we can capture all requests that starts with 5. So any response code that starts with 5, which could be 500 all the way up to 599. So we can use /d and specify brackets 2, which is the regular expression format, to specify 5 and any 2 digits after that. So in this particular case, any status code that maps this particular pattern will be transformed into 500 response at the API gateway level. So let's click save. Let's navigate back here. Let's update the integration request to return a 5 or 2. And let's click save here as well. So let's navigate back and click test. And this time we received the same 500 error calling API even though we were returning a 5 or 2 in the backend code. Since the 200 is still mapped to anything else, all the other status codes will be mapped to this particular option. We can also specify that the request must have query parameters. For this, let's come into method request and let's add a query string. So we can specify a count property and tick this to add a new query string parameter. You can also enforce it being required. Now if we select the required option, it forces you to specify the count property. With the count property, we could start using this inside our integrations. So let's navigate back into the integration request and use the parameter count inside the mapping template. So instead of simply selecting and returning a status code 502, we can conditionally return it based on the count property. Now I have the template already written out, so I'll paste it here and walk you through it. So this is still returning a JSON, as you can start with the starting curly brace and the ending curly brace. Now this uses the velocity template. Now to read the query string parameters, we can use the dollar input and read it from the .params property. Since our query string name is count, I'm reading it by the name count and I'm storing this in a count string. Now I want to convert this into an integer so that I can perform some integer-based operations on that count. So I'm currently parsing out the integer and then checking if the count is less than 20. Now in case this is less than 20, I'm setting the JSON property status code and setting it to be 200. If it is more than or equal to 20, it will be set as 500. So based on the query string parameter, you can see that the response is going to differ in this particular case. So let's save this and let's test this from our endpoint. So let's again go into test. If you simply click test, there is no count property being sent, so it responds back with an internal server error and the status code 500. This is because it is trying to parse the count property which does not exist. We could add in smarts to check that as well. But let's add the count property here now and let's pass this a value of 10 and click test. Now you can see this maps it to the 200 status code and returns the hello REST API message. If the value is greater than 20, so let's say 25 and click test, this is going to return back the error calling API. So we have conditionally switched our mock API behavior based on this query string parameter. When building backend integrations, you can pass these query string parameters and change the behavior of your APIs in the backend services. Now, since this is a user's endpoint, we don't want to be simply sending back text messages. So let's update our response to return a JSON object. So let's expand the 200 method response status. Let's select the application JSON. And instead of selecting the hello REST API, let's pass some mock user data. Now I have some already created. So let me paste that in here, which is simply returning a list of user objects, and it has the properties ID, name, address, and email. Now this might be how your API backend service is going to return whenever the /users is going to be hit. So right now I'm able to build a mock endpoint so that anybody who is going to work on this API already has some mock data to work with while I'm building the backend services. So let's save this and see this in action. So let's come back to the test and click test with a count of less than 20 and click test again. Now you can see it returns back an array and it has all the user data that we just set up. Now if you want to conditionally return data, you can do that as well in that template. Just how we used the count property, you can filter out the data from this JSON, etc. With the get endpoint working, let's add a new endpoint. So similar to before, let's select the resources, that is the /user, let's select actions, and let's specify create a method. Now in this case, let's select a post method and click the check mark. Now this is again going to ask the similar integration type. So let's use mock and click save. Now this is going to set up a different post method, and this has completely new options. Now if you go back to our get, we have a different set of options that we have already enabled for the get endpoint. Similar to this, we will need to set up our post endpoint. Now if we simply select test and click the test method, it is going to return back a 200 no data. This is the default option that is set up for this endpoint. Now even if we pass some request body, let's say we are going to pass a user that can be posted inside the JSON request body and test this again, this is going to return exactly the same because right now this is not doing anything. Let's say we want to add validations on this request body so that all the properties are specified, and in case there is anything missing, it will automatically respond back with an error. For this, we need to first define a model for this particular user. So let's navigate to the models section inside the API gateway and let's add a new model. Now you can see by default there is an error and an empty model that is defined. So let's click create and create a new model and call this user. Now we can specify the content type. So this is going to be application/JSON, and let's specify a description, which is the user model schema. Now this requires a JSON model schema to be defined for this user object. So let's navigate to a JSON schema generation tool, which I'll post a link in the description below, and let's build a model for this. So let's paste in our sample request type, which has the ID, name, address, and email. Let's select settings. The AWS API gateway expects a draft 4 specification. So let's select that. And it also expects only certain properties inside the schema. So let's select only that. In this case, I have selected schema, items, properties, and type. And let's click save. Now once we have pasted this in, we can click submit which generates the schema for this particular user object. Once the schema is generated, let's copy this and use this inside our model. I will put a link to this particular schema generated by here in the description below as well. So let's come back, let's paste this schema in here, and let's create the model. Now this has created a user created model which specifies we have a ID, name, address, and email property and the associated types of them. Now if you want to add more properties, you can do that and update the schema here. Now once that is specified, let's come back to our resources. Let's go to the post endpoint. Let's select the method request. Let's specify the request body, and we can specify a model here. In this case, we know this is going to be an application/JSON, and let's specify the model name as user, which is the one that we just created. And let's tick this. Now, if we want to enable validation on this, we can select the request validator and select the option validate body and select the check mark. Now, anytime a request comes in, it's going to validate the body and it uses this schema definition here. So let's come back, let's click test, and let's select the test again. Now in this case, it says an invalid request body because we haven't specified any body. So let's paste in a sample user data. So I'll use Windows V to open the clipboard manager and select the user data and click test again. Now when all the properties are specified, it returns back a 200 status. Now if we remove one of these properties, let's say if we don't pass in the email and click test, this is going to return an error invalid request body. Once we pass in the full data, it again starts sending us back 200. Now if we want to update the response body, you can also do that inside the integration response. So here you can expand this, you can click the mapping templates. Let's say add mapping template for application/JSON, and let's select this. We can specify a return message, user added, and let's save this. So anytime a user is successfully added, it is going to return this message. So if we come back to test with the proper request body, if we click test, you can see the message user added. You can also mock this to send the exact same request back to the user so that the same user body is being returned back. Until now, what we have been doing is building the API definition. So we have been building the resources section and testing it locally inside the API gateway. But this API is not accessible from an outside URL. To use this API from a URL, you'll need to publish or deploy this API to a stage. Now, a stage is nothing but a logical reference to a lifecycle of the API. For example, development, test, prod, beta, etc. Or it can also be different versions of your API. So let's see how we can deploy this API to a stage and using this from a URL from outside. So let's click Actions and choose Deploy API. Now this is going to pop up an option to deploy to the stage that you want to. Now in this case, since we don't have any stages defined, let's select New Stage. Let's give this name as Dev and give this description as Development API Stage and click Deploy. Now this has deployed the API definition that we have created here into this particular stage, which is Dev. So if we expand this, you can see the different resources that's part of this API endpoint. Now if we select the Dev endpoint, we can also see the URL that you can use to invoke this particular API on this stage. So if we click this URL, it is currently saying missing authentication token because we don't have anything defined at the root of this API. So let's go into /users, let's specify account property, and let's say 10. Now if we invoke that, it is going to return our mock data. Now if the count is greater than 10, you know that it will return an error calling API. You can also post a request to this API endpoint. To make a post request, let's copy this URL. Let's open Postman, which is an application that you can use to create HTTP request. I will put a link below in the description and it's freely available to download. Let's click a new request. Let's select post. Let's paste in this URL. Let's remove the count from the query string and let's click send. Now, since we haven't specified any request body, it returns back the message invalid request body. So let's go into the body and let's pass in the data. So let's select raw. Let's select the option as JSON and let's pass in the sample user data and click send. Now this returns the message user added as expected. If you remove one of these properties, it is going to return the error message because of the validation that we have enabled. The stage has different options that you can enable to configure this API endpoint. You can enable the API cache, you can enable throttling, and also a lot of other properties. So you can see here, this gives different options that you can configure for this API endpoint. You can also specify stage-specific variables. Now, in this case, let's add a new variable, environment, and let's give this a value dev. Now, based on these stage variables, you can also connect to different backend services. Let's say when you're deployed to a development environment, you want to use a development version of your Lambda function and also a development version of your DynamoDB. In this case, you can use the stage variable to determine which stage the API is deployed to. Now, if we come back to our resources, if we go to our get method, we can use this, for example, in our integration response. So let's say inside the error response, let's go to the mapping template, let's select application JSON, and instead of just saying error calling API, let's also specify the stage variable. So we can use $bracket stage variables, which is where we'll get all the stage variables, and use the env variable that we have just defined. So now this is going to append that environment variable to the message that's returned back. So let's click save. Let's navigate back to the API. And if we refresh this, this is still going to return error calling API. This is because we haven't deployed the changes that we have made to the stage that we've created. Now, any changes made inside the resources section lives here until we have deployed this to a stage. Think of this similar to making code changes and pushing this to a GitHub repository. Only when you click the deploy button will that version of code be deployed into your particular environments. So let's come to actions. Let's click deploy API. Let's select dev. We can also add a description so that we know what this deployment was for. So let's say add environment stage variable and click deploy. Now, if we come back to our API endpoint and refresh this, now it starts returning the -dev inside the response. Now, if we were to deploy to a different stage, so let's come back to resources, let's click actions, deploy API again, let's choose a new stage, and this time let's name this as test. So let's say test stage and create deploy. Now, if we go to the test, we can specify the stage variables like before. So let's add a new variable and call this as test. Now, if you see the invoke URL is different from that of the dev one. So let's select the test invoke URL. Let's pass the /users and specify count is equal to 25. Now this is going to return the message error calling API with the test stage variable. We can use this stage variables to connect to different backend resources inside our integrations as well. I will show this in detail in a following video where I use Lambda functions to build the API backend services. Now the stages also enables us to roll back deployments. So if you go into the deployment history, you can see all the deployments that's happened inside this particular stage. Now here you can see there is an add environment stage variable name deployment. So that is the current deployment. So you can also see there is a tick mark on that. Now if you want to roll back a release, you can easily go back to a previous release and deploy that one as well. So let's select this and let's say change deployment, and that's going to change the deployment to that particular stage. Now if we refresh this message, it is going to return back error calling API. To roll this back again, just select this and say change deployment, and that becomes the current deployment. So if you refresh this again, it's going to return the -dev in the message. We have barely touched upon a few features on what the API gateway has to offer. I hope this gives you a good understanding of the different building blocks of the API gateway and how these fit together. Now, while in this example I've just used a mock integration, mostly to keep the demonstration easy, I will show you how to build real-world APIs using Lambda functions and DynamoDB databases in a follow-up video. Now, if you want to be notified when that comes out, make sure to hit the subscribe button. If you have any questions or feedback, please make sure to leave them in the comments below. And if you like this video, don't forget to hit that like button. Thank you and see you soon in the next video.